Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. Here is an example about how to apply Newton's laws to solve problems. This question is from 1987 AP Mechanics C exam. An adult exerts a horizontal force on a swing that is suspended by a rope of length L, holding it at an angle theta with the vertical. The child is in the swing, has a weight W in dimensions that are negligible compared to L. The weights of the rope and of the seat are negligible. In terms of W and theta, determine the tension of the rope and the horizontal force exerted by the adult. So in order to determine the force, we need to draw a free body diagram. So here is the free body diagram. Here is the child. Okay, the child has a tension from the rope. The child has a horizontal force from the adult. The child has gravity from the earth. And here's the tension. The rope forms an angle with the vertical. That's the theta. Because the child is at rest, so all the forces cancels out. The force in the horizontal equals to 0. The force in the vertical also equal to 0. The force in the horizontal to the left is F. To the right would be this part. And this part of T is really T times sine theta, because this side, horizontal, is opposite of theta. So we use sine. F equals to T sine theta. In the vertical direction, T times cosine theta, that's adjacent to cosine theta, adjacent part, equals to W. So W equals to T cosine theta. So from here, we can figure out the tension in the rope. So tension is just W over cosine theta. That is the first question, the tension of the rope. Now, in order to find F, we need to substitute tension in this equation. So F equals W cosine theta times sine theta. Now, we all know sine theta divided by cosine theta equals tangent theta. So the horizontal force exerted by adult is F equals to W tangent theta. So these are in terms of W and theta. So both are in terms of W and theta. Next part. So adult now release the swing from rest. In terms, again, of W and theta, you need to determine the tension in the rope just after the release. The swing is instantaneously at rest. Let's take a look. Again, we need to find the force. We have to draw a free body diagram. So at this point, the adult doesn't hold the child anymore. So there are just two forces. One is T, one is W. Even though the swing is at rest, but the swing is not in equilibrium. As a matter of fact, it is accelerating. It's accelerating in the tangential direction at that moment. So we use this tangential direction. Tangential that means it's perpendicular to T. That direction going down is your positive X. The one perpendicular to that X, that's just the Y direction. Okay, so we know the swing is not moving, as a matter of fact, in the Y direction. So sum of the Y forces equals to 0. Sum of the force in the X direction produce the acceleration. So Fx equals to max, sum of Fy equals to 0. Let's take a look at Y. We have T is positive. The other Y is from W. So W cosine theta. That's the one adjacent to the angle. That's W cosine theta, and this T should be the same. T equals to W cosine theta. And that is the tension in the rope just after the release. W sine theta, right over here along x-axis, that is the force produce acceleration. Question D, the tension in the rope as the swing passes through its lowest point. So let's take a look. Here is the swing. At lowest point, the child will be here. At this point, there are two forces acting on the child. T is upward and W is downward. The sum of these two forces provides centripetal force. So sum of the forces causes centripetal acceleration, And this is t minus w. T is because t is upward, and at this point acceleration is upward. Minus w equals to mac. Centripetal acceleration is just v squared over r, and in this case r happens to be L. So t minus w equals m v squared over L. So again, we have to represent t in terms of w and theta. So over here we have two terms that's neither w nor theta or m. So what is v? How do we find velocity at this point? We can use energy conservation, because if negligible air resistance, if air resistance is negligible, the energy at this point is the energy at this point. Energy at this point, we have potential energy, mg delta h. Energy at this point, we have kinetic energy, 1/2 mv squared. So those are the same. Energy is conserved. From here, we can figure out v. But what is delta H? Delta H is this part. This little part equals to the whole length, which is L, minus this top part. This top part is adjacent of the top triangle, adjacent to theta. And that top part is L cosine theta. So delta H equals to L minus L cosine theta. We substitute this in. We can solve v squared equals 2gl 1 minus cosine theta. We simply factor the L out. Once we have v squared, we can substitute back into this equation. T minus w equals to mv squared over L. That equals to m times v squared is 2gl 1 minus cosine theta divided by L. This L and L cancels. So we have T equals to, move W to the right side, becomes W plus L and L cancels, M times 2G, 1 minus cosine theta. But what is mg? Mg equals to W. So we change mg to W. We can rearrange it. You should have T equals to W times 3 minus 2 cosine theta. That's it. I hope it helps. Thanks for watching.